Okay, good afternoon, everyone, and thank you for watching one more INB live space. Today, we have the pleasure of hosting Anton Maertens. He will be talking to us about CO2 neutral building materials from BC Materials, an incredibly interesting topic and very actual, which we'll be looking at in detail. Let me first of all, thank our sponsor for this live space, the company Cooker. Cooker has been developing these superb filtered water taps. So basically, these taps have an integrated filtering system. They're also very aesthetic and easy to integrate anywhere. You can ditch the water heater as it serves cold and hot water, and of course using a lot less plastic for bottles, since you can have perfectly drinking water from it. So let me go back and just quickly introduce LiveSpace for those who are watching it for the first time. LiveSpace is a series of interviews we started last year. So the Association of Interior Architects of Belgium, AINB, we do a lot of different events, a lot of activities for our members, and this is one of them. We wanted to share some qualitative content out there with our members, but not only. And we started interviewing interior architects, Belgium, working in Belgium, but also working abroad. And we also wanted to have to listen to the opinion and the experiences of other people in the construction industry, particularly in interior architecture, such as Anton that joined us today. Since they are the builders, they are the manufacturers, and the collaboration and the beautiful things we design are only possible thanks to them. So let me go ahead and add Anton to the stream.
Hello, Mauro. Good evening, everyone. Thank you for having us and inviting us, and thank you for the kind words. We hope to live up to the challenge that you posed.
Anton, it's fantastic to have you here. Like I told you earlier on, I heard about what you were doing. I didn't have personally the chance to work with you, and it's fantastic that we can offer today to our members the opportunity to have a deep dive. Maybe I would like to ask you first, what is your background and how did you find yourself or your way into the construction industry?
Yeah, I have a bit of a particular parcours, you could say in French, like a different trajectory as most, in the sense that I used to be a policy advisor and I studied communication. But about 10 years ago, I started renovating together with my wife our own house that we bought at the time from 1904. Lots of stuff needed to change, and I was surprised that even with the renovation, we think we filled about 2 to 3 containers filled with waste, and we tried to reuse as much as possible. But we noticed that how well we tried, that a lot of the materials are not made to be reused or not made to be reintegrated again into your own project. Obviously, it's recycled, but it's usually downcycled. So when I met the people of BC, I was very intrigued by this story, and I offered a bit my capacities, my modest capacities to them. And I also studied renovation coordination after my renovation. So I actually studied something that I could have used really well during my renovation, but that gave me a bit of a broad vision on building materials, building needs, and also a bit of architecture, but not in the classic sense.
Yeah, I'm trying to show here actually an image of. I'm sorry. Let's try it this way. I have to come back. Okay, and now let's see if this works. There we go. So what is the future of building? And I think this will take us to BC indeed, and what you stand for.
Yeah, one of the things I noticed when I was renovating on my own, and it's a question that not a lot of people ask because it's not an obvious question, is that where do our materials come from and how are they produced? We usually buy them in one of the bigger shops or in one of the large material shops, or the entrepreneur buys it for them, the contractor buys it for us. And so we don't always know what our materials are made of and how they are made. And actually, the challenge for the future builders and future architects will not be simply to make an eco-efficient and energy-efficient building, but also one that is decarbonized in the materials itself. So you have a lot of pollution that is caused by construction. It's actually a beautiful sector where you can do fantastic things, but it also has an ugly side, creating a lot of waste, creating a lot of emissions. And so these 30 to 30% emissions, 30 are from heating and cooling that will be decarbonized in the future through heating pumps and solar panels. But the 10% of the materials themselves, how we produce the materials, that's really, really, really difficult. And you'll see a bit in the next slide why we are really facing an existential challenge. It's just not simply an ecological challenge that we're facing. We're facing coastal areas that are being submerged by rising sea tide and by flooding. We had it in Belgium, but it also happened in Germany, in the UK. It's not something that is far from us anymore. That only happens in very vulnerable areas. We are part of the vulnerable area. In that sense, we really have to speed up with accelerating and decreasing CO2 emissions.
Absolutely.
And so part of the solution for us at BC lies in the waste that is produced by construction, because a lot of construction sites need to excavate earth, and the quantities are gigantic. And for us, it's not just waste, it's really a tool, an ingredient, a resource. And you can see the numbers, 2 million tons. For a lot of people, it's inconceivable. You cannot imagine how much or how you could see it. It's just tens and hundreds of trucks a day that are passing from Brussels to Walloon, sometimes to the Netherlands, because the earth is just transported and deposed in mines or quarries. At the most, it is used as a kind of foundation for a road, and that's the maximum that you see how it's used. But we see it more as a real resource that can be used, for example, to make these compressed earth blocks, as we did for this project in Antwerp. It's close to Antwerp. It's in Edegem, actually. So on this spot, we made with earth from the side next to it 20,000 compressed earth blocks. So it was not that we went to the factory and just ordered it. We wanted to see if we could produce on the spot blocks that could serve the purpose of a bioclass. And the bioclass was an assignment for the commune of Edegem, where they wanted children to learn about nature and environment. And we thought that it was the best way to show how they can learn about nature and environment by having a very clean class, a very CO2 negative, ideally, by, for example, using hempcrete on the outside as an isolation. It's something that you can, hempcrete, I don't know if people know it, but it's actually a mix of hemp and lime. Hemp has a bit of a bad reputation because obviously it's also cultivated for people who smoke weed, but there's also hemp that is just very low on THC, and that has numerous applications in agriculture, such as oil, clothes, and construction. So by mixing lime with hemp, you can have a very thick isolation that has a good capacity. And that is CO2 negative, because you're actually increasing the coverage, the capture of CO2 by the hemp that is growing, and by adding the lime that you still have to burn. So from the outside in this project, you can see the hempcrete, and in inner walls, you can see the 20,000 compressed air blocks that we produced on the spot. Actually, the hempcrete we also produced on the spot, and the big advantage of these compressed air blocks is that in comparison to fired bricks, they emit 90% less CO2. You can reuse them. You don't have any waste because you can calculate exactly the kind of the quantities of earth that you need. You have zero air pollution because a lot of producers have to burn fossil fuel to produce something, and that obviously emits not only CO2 emissions but also NOx, fine particles. So you have a whole asset of advantages to producing locally without having to burn, and you have the better acoustics and the life quality inside the building that is much better, actually.
It's a fantastic example, and the fact that you produce it on site, it makes even more impressive. There was a specific project which launched BC Materials. Maybe I can come back to this picture. I think it's this one. Maybe you can tell us a bit about this.
Yeah, it's really the roots of BC. So Brussels BC is actually like short for Brussels Cooperation, and it's 10 years ago that it's almost 10 years ago that the founders of BC went to Muyinga in Burundi, a very small village, really in the heart of Burundi, very isolated, and we had a mission there to build a library for the blind. And the problem was that when we arrived there, that we immediately noticed that all the traditional materials that we know from every kind of education, architectural or construction education, is that it was just simply too expensive to import it. We only had a budget of like 20,000 euros. So when we had to construct that building, we noticed that it would be very difficult to do it with traditional materials, or if we had to bake bricks on the spot, that we would actually have to cut the lovely trees behind this building and make it more difficult for farmers, for irrigation, and for the cattle that was present. So we started talking with people on the spot, and there was a local contractor who explained to us how you can build with raw earth. And so we were really surprised that that was a possibility. I think for a lot of people, it's still strange or extraordinary that you don't have to burn earth, or that you don't have to burn a kind of material to build it. But it's also really a matter of dosing and dimensioning. And so in this project, we learned, thanks to the local Burundi contractors, workforce, and really the community, that we could, together with them, build this. And so when we came back to Belgium, it was really like a revelation that we wanted to apply it in our own projects, first for the architectural bureau. But the more that we noticed how many quantities that we just shown, 2 million in Brussels alone, 2 million tons in Brussels alone, but 37 million tons in Belgium, we saw all that excavated earth, of which we know that it was from a good quality, that we made the tests and that we saw, well, you can actually use it in construction. And maybe we have to push the construction sector much more and start producing it and offering it to the market. So we have two examples of how we can work. We can work on the spot, as we did in NCBHAM, where you just produce on the construction site itself and you intervene in after the extraction. So we start to produce on the spot some of the building materials that is needed for the construction project itself. Or we can intervene in the transport, because all that earth obviously also has a transport cost in economics and in emissions. And so we intervene, for example, in Brussels, and we can use the earth to make a kind of stock and produce in Brussels, in our own production spot, the materials that can be used in everyday construction and everyday architecture. And so we can currently we mostly produce just in time, because orders come in and we are in the city. It is expensive to work in the city, so we try to produce just in time and not to have too much stock. It's really a matter of productivity too, that we want to avoid having too much materials. And here you see the three materials that we make. It's a briquette, it's a compressed air block. You can compare it with for example, a brick. The brusselaire is the clay plaster that is used to finish walls, and the castar is a really bespoke, very specific material. It's actually a rammed earth. You can use it for floors, for walls, for furniture, for every kind of object that you can imagine. And you can consider it a bit as an ecological concrete, where concrete is usually a mix of cement, sand, and gravel. You can see on this picture here, for example, on the wall you have the brusselaire gray that is finished a bit in a stucco way, in an artistic way, with more flue. And on the floor you can see the gray rammed dirt, the gray castar, that is on the right side unpolished and on the left side polished. And on the front you can see one of the objects that has been made in a workshop, a tabouret, a kind of sitting stool in rammed dirt. And rammed dirt literally says it all. You really have to ram it. You really have to put force into it to get to these kind of materials.
And in terms of, I mean, because the pictures we are showing, I mean, they all the materials are looking very tactile. There's texture to it. I suppose there's also specific smell to it. Well, this life space is directed in priority to interior architects. Interior architects are clients of yours. They are getting to get acquainted with your products. How is this going? What they are looking for when they contact you?
Yeah, we have a nice connection and touch with interior designers, because we feel that they're also considering more ecological materials than maybe 10, 15 years ago. I think they like the tactility, as you mentioned it, of the materials, and the fact that it's very difficult to make these kind of materials in a chemical, artificial way. If you would want to make it look like this in another way, in a non-natural way, it would be very difficult. And on top of that, I also think that interior designers are probably a bit more sensible to aspects like acoustics, aspects like air quality. They are very close usually with the building clients. They when the project starts, they probably see them on a day-to-day basis, and they want the best for their clients. And in that sense, you have a very healthy material that is also that can also be aesthetic, that can also be bespoke, very specific, and that has the extra advantage of being very ecological. And here you see a bit of a special project. It's actually U-Square. It's the transformation of old police barracks in Etterbeek, close to Ixelles. It's actually the future housing and classrooms for students of the VUB and the ILB. And on the downside, where you see like the slick clay plaster, it's a classic clay plaster. But on the top side, you can see an acoustic plaster that has been mixed with hemp and cork. And usually, if you would put it on the downside, it would be frickle and touchable and degradable. But because we put it on the top side, you cannot really touch it. Indeed. And it has the better acoustic qualities because it has a very rough finish. Mm-hmm. But I guess, I mean, when I show this picture to people, they're not only thinking about the acoustics, they see a very, very peculiar, unique aesthetics that is blending in with the space that has been transformed. You see the old and the new in one space, and I think that's one of the reasons why this works, or why I would imagine that this works also for interior designers.
Mm-hmm. It's a astonishing picture. In terms of usability, the the decorative plaster that you have on the lower part, since it's a classroom, you were saying this future classroom. So in case of damage, how repairable are the plaster surfaces, or how easy repairable are they?
Yeah, it's very repairable, and in that sense, I think every finish of a wall can have damage and can be punctured a bit or aggravated. But in this sense, I think clay plaster is useful because it's easy to fix. It does need some maintenance when it would be touched, like most materials. And in that sense, a gypsum plaster can also be maimed and also has to be retouched if necessary. I think the one of our clients once said that he forgot to close his velux above his bath, and so his clay plaster had flushed part of it into the bath, and so then afterwards he could really fix it really well, because we usually give to our clients like one bag of a few kilos of clay plaster, so people can, if they want to, fix it themselves instead of having a contractor over for just 1 or 2 centimeter that has damage. In that sense, I think the material is really very forgiving. It's very reusable and always in touch with the idea of a material that doesn't need to be rock strong. And so we are big fans of clay plasters because we have there's abundant research that they regulate humidity, in that sense improving the air quality, something which has only become more important over the past years. They improve the acoustics, and something that is also a bit climate related is that they mitigate temperature because they offer a lot of mass. You have less fluctuation in a space with earth plasters than in a classic space. If you see at the heat waves that have happened in summer, it is a form of air conditioning that is quite practical and that is way less energy intensive.
Fantastic. And you have been working on in terms of the quality of the finish, or the how should I call it, more the regularity of the finish. We see a lot of texture, but we also see that you have surfaces that are more clean or more regular in terms of the finish. This is something that you are experimenting with.
Yeah, I think it's something that people underestimate with earth materials and the way it looks and the way it's finished, that you can really finish it in a very diverse array of ways. You can do a real stucco effect where you have a kind of flou artistique that is making the space, or you can do it in a very classic way where you can see the kind of mini gravel in the spots. And it's really up to the client or the interior designer, whatever his or her plans are, what she wants to, which kind of effect she wants to see. And I think earth is really breaking out of the traditional building culture, in the sense that it used to be something for people that were super focused on sustainability alone, and it's more and more used in other projects where it's just used as the obvious choice for a finish. And I must say that this is something that makes us happy, because it's a good way to integrate healthy materials into a project.
Indeed. We are tell us what we're looking at here. These color tones.
Yeah, I'm a big fan of this color tone because it reminds me of the Mediterranean a bit. What are we looking at? This is really leftover quarry wastes mixed with algae, and it's a project that we developed with the Luma project, Luma Foundation in Arles, so the south of France, that have also a lot of experience with algae and the different applications or uses of algae in the Camargue. And so you see here that you can, where usually earth colors are going towards gray, brown, white, or a whitish kind of, that you can experiment with these kind of materials towards a warm kind of blue, a warm kind of green, even yellowish colors. And it's really a matter of how much algae residue you put into it and which kind of effect it does. But I would love to talk more about this material. But the fact is that we have just experimented with this material this year, and this was also on show in at Dutch Design Week for the past week and a half. And I think it looks wonderful, but we still don't know a lot about it, and we still have to test which kind of effect it has in acoustics, in abrasion. And so I'm a big fan of it. I would love to develop it, but we will see how qualified and which kind of characteristics it has.
You have been working on, well, a lot of bespoke projects, and amongst the photos you have shared, this is one, well, some actually that we will go through, that I wanted to show our viewers, of course, with your comments, in what seems to be, well, the front face of this counter with this beautiful texture.
Yeah, this is the Bar Nief in Antwerp. It's as some of you may know, it's a ram dirt bar. One of the things that we specifically liked about this project is the collaboration with the interior designer, but also with the people who ordered the bar, the people who are running the bar, because this is a ram dirt bar made to fit, but also really produced on the spot with the employees of the bar and volunteers. So you can really, ram dirt, it's very important that you coordinate it well, that the structure is well applied, that you have good preparation, that you have the right tools. But once you're on the spot, you can really work together with other people and start ramming literally together to do layer after layer. And you can see it on the photo on the left or on the right, a matter of interpretation, that you see these layers of about 10 centimeters. And that's really the way that ram dirt is applied. You have to apply it in layers, ram it, and then go towards the next layer. So it's a very labor intensive, but for a lot of people, it's also kind of fun to do it, because I think especially with the quarantine, we've all been behind our computer a lot of the time. We've been stuck inside. And so you notice that when people are working with healthy materials, and that they can just work and shape and form it as they see fit, that it's actually very liberating and very, very fun to do. And you can see it with these pictures that something like ram dirt fits for a lot of projects, and that it can really bring an extra asset to whatever project. And in this case, it's a bar that is quite popular in Antwerp, that really has a kind of eye catcher that really draws in people.
It's beautiful, and also you can see in the picture before how you can work it on very flat, straight surfaces, also on the round with a small diameter curve, and it just fits in beautifully. And the specifically on the top part, you have a sort of a varnish, finishing varnish that gives the protection. Is it a counter that is used a lot? Do you have can you have a protection, for example, for acids? Can it be used on the food environment? Just a question, since we are doing.
Yeah, of course. Very, very justified question. In the sense, we usually recommend a carnauba wax, which is like a nut oil that really protects the top side from water and humidity, so that you are able to clean it. Would we recommend a ram dirt countertop for when you cut food? Probably not. Mm-hmm. There we would say it's better to work with, I don't know, secondhand granito or marble or wood for example, oak or a different kind of clean material that can be really easily applied on a ram dirt, and that has the right capacities to capture any kind of I'm not going to say pollution, but when you start cutting your material on a kind of ram dirt countertop, at some point there might be some infiltration. So we would not recommend it for the top if you are going to clean, or if you are going to do really cuisine a lot and cut a lot of vegetables on it, for example.
Yeah, makes totally sense. And coming back to the flooring, which is also a product you are fabricating. We see here two different pictures. Can you tell us a little bit about the flooring and the qualities of your product?
Yeah, so here you see a ram dirt really applied as a floor. When you apply a ram dirt as a floor, you usually need about 7 to 10 centimeters in thickness, so it's quite thick. I think the nice part about it is that you can really make it with materials that are considered as waste or as gravel from construction projects, really from demolitions. So you mix gravel, clay, and sand into a very finely tuned mix to start pouring it as you do with poured concrete, and you can polish it afterwards. And I think the nice part about it is that it has a very authentic, unique look. No two ram dirt floors ever look the same. These are pictures of one and the same ram dirt floor, and even the left one looks a bit different as the right one. So it's really a floor with so much texture. And then obviously from a producer's point of view or a materials point of view, it has fantastic capacities, such as the fact that it can be produced in a CO2 neutral way. It's 100% circular. So if you would reuse all this earth after 50 years and just take it away, you can still reuse it somewhere else. And for some interior designers, it can be good to know that, for example, like heritage departments, they like ram dirt because they know that when it's applied in a protected building, it's not something that will make or that will leave an ineffable damage. It's always something that can be retaken again without leaving any harmful substance on the present materials. And so here you see kind of different applications. The right one is still a floor. The middle one is one of the stools that we made for a project here for a Belgian magazine. And so on the top you see really the polished gravel and the uniqueness, the texture of the gravel with the carnauba wax that makes it shinier and also protecting it from being easier to either get loose or become affected by humidity or something like that. And so the left one, you see the ram dirt in a kind of structural way, because you can use the ram dirt in furniture, as we've seen, and in floors, but it can also be used in a massive way. So in the sense that you can actually build with it up until 15 meters or even further. And so you have this unique texture from the outside where you kind of see the gravel layer after layer. And it can be really quite a sight to see. Again, with ram dirt, the nice part about it is that the texture is always so unique. And once you know how it's made, and the fact that it's really, there's no toxic element in it, not in the production, not in the eventual product, it's really, really a super material.
Yeah, this is what I also find surprising in what you are showing to us. It's the diversity of the textures are they're very different from each other, and that they're all giving a lot of identity to all of the projects that we have been looking at. I will maybe share some more. I see time is running. There's so many nice, interesting things that you're looking at. Maybe you can tell us a little bit about this. About this topic.
So for Dutch Design Week, we were asked to make two things, and yeah, it's actually a bit unfair of me because the left round earth wall is made with our materials, but it's done by the excellent artisans of Limniscaat, which is a known earth contractor in Belgium here. It's an excellent round earth wall that they really wanted to put outside of the building. The building is called Beyond Building in the sense that they wanted to show what is possible with all kind of bio-based, geo-based, and non-toxic, non-fossil fuel related materials. And so you see from the outside that you can have a fantastic round earth wall as a construction, as a kind of future wall for any kind of project. And on the right side, you see the blue algae plaster that was used next to mycelium panels, I think. And it's really this kind of texture. It's really difficult to make if you would want to make it in a chemical way. But once you start working with leftover materials, you get a kind of texture that would be very difficult to obtain if you would want to obtain it in a chemical way. So yeah, we think that especially in this project, because you have all these combinations of interesting materials, that it's not really the future that we're seeing here. It's just the reality of what is possible with the materials of today. And we just have to start applying it and really focus on it. Which kind of materials do we want? What do we want to use? And which kind of impression do we want to give? I think you're on mute, Mauro, because I'm not hearing you.
Yes, thank you. It feels like suddenly feels like a Teams meeting. So there's a quite an important project for you, which you are currently working on, subway station here in Brussels. I suppose these pictures that you have selected are pictures from the site or the future site.
It's not the future site because we're not there yet. I think the picture is actually from a subway station in Germany, but it's just to give an impression of what happens on a day-to-day basis in a lot of European cities. They are investing in public transport, for example, as a subway, because it's a good way of creating more transport possibilities and cleaner transport possibilities. But it's also a fact that if you do a subway, that you're excavating millions of tons of clay. And for example, in Brussels, I think there are going to be 7 new metro stations from the North Station towards Bordeaux. And we suggested to the building client of the subway stations that it would be a possibility to transform this clay into blocks that could be used to build the subway stations. And they also have a very circular approach. They also have a very circular mindset. And so they were very interested. And now we have a kind of letter of intent where we want to research how it's possible to really transform these giant amounts of clay that would be a nuisance anyhow to have to depose them or to have to transport them. And so we're also doing it because it can be a real catalyst to reduce the price by going on a higher scale. And for us, it's really, we want to make it as accessible as possible. And the blocks are something that can be used in practically every project of any kind of construction.
And you have this particularity of also being able to adapt the scale and shapes of the blocks, like we see in this picture, for example.
Yeah, this is also a very bespoke project in the sense that you see here in total you have 9 tons of rammed earth. It's actually 600 modules that are all made manually in that sense, it was a very time and labor intensive project for, I guess, a special client. And really, the rammed earth was made with different textures on purpose to have a kind of desert look. For me, and for some people who know about earth building, this looks a bit like Yemen, but then in a very small version, as if you're walking around there. It's like a New York version of earth construction, and we had to make these 600 modules for Hermes for their interior of the shop. And so we really, on the basis of their instructions and on the basis of their color scheme, we made these 600 modules, installed them with a French contractor on the spot in Paris. It was quite a hassle to get the truck there at the spot.
Yeah.
We had to install them at night too, because the shop was open during the day. But you see that even bigger brands like Hermes is really moving towards more circular, sustainable materials that have this really unique texture and a unique appeal to people.
Mm-hmm. Mm-hmm. We will go through one last project as we're running almost out of time. I'll just move on to this. Exactly, this is the Golden Wheel. So what are we looking at?
So the Belvedere on the right is a watchtower, and it's made with mostly everything that you see on top of the concrete foundation is rammed earth, made with earth from the river Meuse that runs across it. It's actually a watchtower in a natural park, and we thought it would be good if we could use the local earth, actually the part of the dredge actually of the Meuse, to reformulate a rammed earth mix and to construct on the spot a watchtower built with the rammed earth. Mm-hmm. And so the Houden Lineal architects designed this building, and we reformulated the mix and accompanied the contractor to build this watchtower that could essentially return to its origin, to its earth ingredients in 100 years, if we would decide to demolish it, and it would leave no waste at all. It's just a very nice building in the middle of a natural park that is built in the most natural way I think you can do.
Mm-hmm. I wanted to ask you in terms of cost pricing, how do clients end clients react to the cost of your products, and how do these products compare with much lesser cleaner products that are in the market?
Yeah, good question. It's important to answer that because for example, a clay plaster in price, it's practically the same. There are less contractors that can apply it, so in that sense the application can be a bit more expensive, but the price is roughly the same. For the compressed earth blocks, we are really working on scaling the productivity and really reducing the price so it can become a standard block. And then for the rammed earth, it's really a super specific material, in that sense that the client that wants it has to be really committed to it. And because it's so intensive to apply, the price can be quite high. For a rammed earth floor, for example, a contractor will ask about 200 euros a square meter, which we realize is quite expensive. But actually, we know from working with rammed earth, from applying a rammed earth floor ourselves, that the costs are legitimate. And in that sense, a rammed earth floor is so much work for a contractor. It has to be done so well that we know that the costs are not exaggerated or pushed or squeezed towards the client, but it's just a very complicated way of laying a floor that has a lifetime of quality, no waste, and is complementary with floor heating. In that sense, it's always weighing a bit the advantages towards towards the disadvantages and obviously the costs and the whole package of the project. But we will never push clients to say like, oh yeah, you should really take a rounded floor if it would cost, for example, half of the budget of their renovation. It's not in our approach to sell materials to people who feel like this is too expensive for them.
Mm-hmm. Anton, one last thing that maybe you want to say to our viewers before we close off the interview, which has been a real pleasure to me, and before I let you go.
Yeah, I just thanks for the invitation and the questions. I think it's really cool that more and more interior designers are looking at how stuff is made. They're also putting their hands in the earth, so to speak, so to say. They're really starting to work with materials. We see them at workshops of ours that we frequently organize, and I think it's a really interesting evolution. And I think it would also make interior design better. As the ecological aspect of the materials are also taken into account.
Fantastic, and it's also the reason why we are inviting trying to invite all of the actors in the construction industry to work better together, to also get the knowledge of what is happening. Different companies are into different efforts, creating products, materials that are greener, that are cleaner, that are more easy to install, or that are more sustainable. And we need to be fed by this information, which of course in busy times architects don't always find the time to go search for this. So it's so important that we stay close and talking and improve what we are designing, thanks to the things you are developing and working on, as you have shown us today.
Thank you.
Thank you very much, and I hope to see you soon, Anton.
Yeah. Take care and have a good evening.
Thanks.
Talk to you soon, Mauro. Ciao.
Yeah, thank you. Have a good evening. So, well, I hope that was as interesting to you as it was for me. It was a pleasure to have Anton giving us such a precise, concise, and detailed description on what BC Materials stands for. Also, the variety of things they are working on, which I personally also wish we can work soon together, because I'm really a fan of the look and feel of the material. So not only it's such a interesting and sustainable material, also it looks incredibly good, with a lot of identity, a lot of texture. So looking forward for that. We will coming back in a couple of weeks, should I say 3 weeks, on the 18th November. It will be another live space interview with René Pierre from Germany. We will be looking at working spaces for sustainable and future-oriented learning in a digitalized world. It's going to be very interesting. I had a chance to meet René already a couple of times, and he will be presenting a couple of projects that are extremely interesting. So hopefully I will see you then, and I wish you a very nice evening.